All right, I think 5.2 is the absolute hardest section that we do in this chapter because we throw a bunch of stuff at you and you've got to have a really good basis in algebra to do it. So I'm going to try and get this done in 2 videos, but I'm going to skip around as far as which problems I do. So I'm going to get all the easy ones out of the way first, and then we're going to go from there. All right, so bottom line is how we're going to start this thing is we're going to undo everything we just did in the last section. So I want to integrate. So everything that you see in this section is going to be a big fat fraction. So if I'm looking at this, I've got the integral of 18 over x dx. So just visually, the very, very first thing that I do when I see a fraction as my integrand, the very first thing I do is I ask myself, is the derivative of the bottom in the top? And if it is, then the answer is going to be the natural log. So if we look at your formula chart, okay, so number 5 says if the derivative of the bottom is in the top, the answer is the natural log of the bottom in absolute values. Okay, you've got to put it in absolute values. So I'm going to kind of break this one down first. So what we have is, I'm going to bring this 18 out front as a constant multiple just to get out of my way. So now I've got 1 over x dx. So again, the first thing I ask myself is the derivative of the bottom in the top? So the derivative of x is 1 dx. So the answer is yes, the derivative of the bottom is in the top. Okay. If that's the case, then your answer is going to be 18 times the natural log of x in absolute values plus c. Now, what happens if your brain gets cluttered and you're like, well, I don't know what to do? Okay, so let's just try power rule on this thing. So if I have 18, and let's write it this way this time. I'm going to write this as x to the negative 1 dx. Well, if I use power rule, if I increase my exponent by 1, that's going to become an x to the 0 over 0, and you can't divide by 0. So that's going to be your first clue that you cannot use power rule on this. So again, the first thing I'm going to look at every time, even all the way through Cal 2, is if I see a fraction or a rational expression, I'm just going to be asking myself, is the derivative of the bottom in the top? If it is, then the integral of that setup will be the natural log of the absolute value of the denominator. Okay? So number 2 says, we have 4 over x minus 7 dx. So again, I can pull that 4 out front as a constant multiple because right now he's in my way. Okay. And then the question is, so that's now a 1, is the derivative of the bottom, which is 1 dx, in the top? Yes, it is. It is 1 dx. So the process of integration is going to give you a 4 times the natural log of x minus 7 plus c. Okay. Pause this for 1 second. Sorry, my husband's computer was behind me and it started talking to me and it freaked me out. All right, so the next one. We've got 1 over, and then I've got 10 minus 3x dx. Okay, so my first question is the derivative of the bottom in the top? The derivative of the bottom is negative 3. I can make that. I can always balance with constants. So what I'm going to do is I'm going to multiply the top times negative 3, and then balance by dividing on the outside by a negative 3, which is the same thing as multiplying by negative 1/3. So now the derivative of the bottom is in the top. So the integral will become negative 1/3 times the natural log of the bottom plus c. Okay. Now what I'm technically doing here is u substitution. And I'm doing the balancing stuff, but we're trying to get you to the point where you don't have to set up that little side thing of the u's and the du's and stuff. So since this is just a basic balance, I didn't write it that way. But technically, if I had, then what you would have looked like is you would have said your u is a 10 minus 3x, which makes your du a negative 3x dx. And then, well, what do I have? I've got the dx, I need the negative 3. So balance with a negative 1/3, and then that would have integrated, and it would have looked like this, either du over u, or you could have written it as negative 1/3 of 1 over u du. Same thing, because du times 1 is du. Either way, your answer would have been negative 1/3 times the natural log of u, and u is 10 minus 3x. Okay, so I'm trying to push you towards not having to write this little side stuff. But if you're more comfortable writing the side stuff, then do it. All right, so the next one is we have the integral of x squared over 2 minus x to the 4th. That is such a lie. This is a 3. X to the 4th dx. Okay, so again, I see a big fat fraction. Is the derivative of the bottom in the top? The derivative of the bottom is a negative 4x cubed dx. I got the x cubed dx. I'm missing the negative 4. So multiply by negative 4 and balance with a negative 1/4. And now the answer when you integrate is going to be the natural log of 2 minus x to the 4th plus a big C. Remember to put your argument in absolute values. You must put your argument in absolute values. If you're a lazy person and you're typing it in, hang on, let's look at my laptop. Okay, right above the enter key, you'll see the backslash. And if you hit shift, that's going to give you a vertical bar. So do shift in the vertical bar, and that will give you the absolute values. All right, so let's do another one. We have number 5 says the integral of 5x to the 4th plus 8 over x to the 5th plus 8x dx. And so now I'm getting kind of freaked out because it's getting messier. But first thing I ask myself is the derivative of the bottom in the top? Well, what's the derivative of the bottom? The derivative of x to the 5th is 5x to the 4th. The derivative of 8x is 8. So the derivative of the bottom is in the top, which means I don't have any balancing or anything. So when I do the integration, I get the natural log of x to the 5th plus 8x plus capital C. Okay. For number 6, and I'm just going to tell you that as we go through this, I'm going to do number 6 on the separate video. 7 is on the separate video. 8, 9, 10, we can do this one. All right, so number 10 says the cotangent of theta over 3 d theta. So remember that theta over 3 is the exact same thing as a third of theta. Okay, I can just take theta times 1 and make it theta. Now, looking at your handy dandy sheet, do I know how to integrate cotangent? The integral of cotangent is the natural log of sine u. So if you remember on the last section when we were taking derivatives, one of the problems was what was the derivative of the natural log of sine, and it ended up being cotangent. So we're just undoing this, okay? Well, now I've got to balance because what's my u? My u is a third of theta, which means my du is 1/3. So I need 1/3, where how do I balance with a 1/3? I multiply by 3. So that's going to become 3 times the integral of cotangent u du. So you have everything you need. And so when I integrate, I'll get the natural log of the absolute value of sine u, which is theta over 3 plus c. Okay, so let's do a couple more. We have, that was number 10. We have number 11. So number 11 is going to be the integral of secant x over 2 dx. And remember that x over 2 is the exact same thing as a half of an x. Okay, so I know I'm going to have to use a little bit of substitution, a little bit of balancing. So look on your handy dandy sheet. What's the integral of secant? The integral of secant is the natural log of secant plus tangent. Okay, so I just need to balance. What's my u? My u is x over 2 or 1/2 x, which means I need a 1/2, so balance with a 2. So now the integral, I've got everything I need, will be the natural log of secant u plus tangent u plus c. Okay, so that you're done. That's it. The 12. I'm going to do 12 on a separate video. All right, so 13, we're going to use integration. Oh, holy cow. Pause the problem. All right, I'm going to squish 2 more problems on this video, and then the rest of them are going to be put on a second, hopefully not third video. All right, so we have an a definite integral. Remember, a definite integral has your limits of integration. So I'm going to go from 0 to 6 of 6 over 7x plus 1 dx, which means I won't have a plus c. So first of all, is the derivative of the bottom and the top? No, it's not. I have a 6, and what I need is a 7. So I'm going to multiply by 7 and then divide by 7 to balance. So when I integrate, I get 6/7 times the natural log of 7x plus 1. And then I am going to take that from 0 to 6. Okay, so when I evaluate at 6, I get 6/7 times the natural log of 7 times 6 is 42, plus 1 is 43. And then minus, if I evaluate at 0, 7 times 0 is 0, plus 1 is 1. The natural log of 1 is 0. Okay, so you don't have a second, you don't have anything to subtract off because it zeroes out. So that is your final answer for that one. And then this one, you can't see it on my paper, but it's shaded between 1 and 3. So you should be able to see it on your screen. Okay, so what I have, oh my goodness, we're going to have to do this a different way. Sorry, I'm going to put this on the next video too, because you're going to have to use substitution on it. All right, so let's look at the last one. We're going to have to do a video on the last one too. All right, so that means I have extra time. So let me go ahead and set up one on this one. And it's going to be using long division. So I'm going to talk you through long division first. And that way we can just dive in on the next. So if I look at this problem, the denominator has a power of 1. And the numerator has an exponent of 2. So that's essentially, in algebra, it's an improper fraction. Your numerator is bigger than your denominator. So what I'm going to do is I'm going to use division, and I'm going to change it into a mixed number. So just as if I had 13 over 9, I would say how many times does 9 go into 13? It goes in, it does not go in 9 times. It goes in once, and then what's your remainder? It is 4/9. Okay, so that 13/9 and 1 4/9 are equivalent. So I'm going to take this thing and I'm going to set it up using long division. So if you want to, you can use synthetic because it's set up for synthetic. But I'm just going to do long division for continuity because you can do long division on all of them. All right, so plus 5x minus 5. So quick refresher on long division. I have an x. I need a 2x squared. What do I multiply x by to get a 2x squared? I multiply it by 2x. So I estimated first, take that 2x times everything out front. So 2x times negative 6 is negative 12x. Put that in the x column. 2x times x is 2x squared. Put that in the x squared column. And now subtract, which means in algebra we're going to change our signs. So your first term should fall off. If it didn't, you did something wrong. And now I've got 17x's minus 5, okay? This degree is 1 and this degree is 1. If your degrees match, you're going to do this round and then stop. Okay, so I have x, I need 17x's. What do I multiply by? I multiply by 17, and so that's going to give me 102, I think. Holy cow, I don't know. I think it's 102. So 17 times negative 6 is 102. 17 times x is 17x. Subtract, which means you change your signs. So I get 102 minus 5 is going to be 97, but let me make sure that I multiplied right. So 17 times 6. Holy cow, I'm right. All right, so what you ended up doing was you changed your integrand to a 2x plus 17 plus a remainder of 97 over x minus 6 dx. And that's where I'll pick up at the start of the next video.